Today's lesson is representing fractions on a number line. The most important part of this lesson is learning to determine how many equal parts are represented between the whole numbers. Let's start with a few examples. So today, students, we're going to talk about number lines and how fractions are shown on a number line. You can see that this line segment is from 0 to 1. But then I might add another point between 0 and 1. Looking carefully from left to right, you can see there's 1, 2 segments. In between 0 and 1, and pretending that this mark is exactly in the center of those two spots, of course we would have 1/2. So this line segment is divided into halves. 0, 1/2, 1. Continuing on with this same thought, we have our line segment 0 to 1. Now perhaps I have added ticks on that line segment. Our first job is to find out how many parts are on the line segment from 0 to 1. So I count 1, 2, 3 parts. I can name these ticks. First we have 0, and then 1/3, 2/3, and then another name for 1 is 3/3. This line segment is divided by thirds. It may seem repetitive, but let's continue with the same idea. Again, the line segment is from 0 to 1. And now with additional ticks, I have to find out how many parts are between 0 and 1. So I begin by counting from tick to tick. We see there's 1, 2, 3, 4. This number line is divided by fourths. Again, we can name the ticks 0, 1/4, 2/4, 3/4, and another way to name 1 is 4/4. What you might also note is right in the middle, we can also name that tick 1/2. If you'll note, the denominator is twice as much as the numerator. Or in other words, the numerator is half the amount as the denominator. Regardless, this line segment is divided by fourths. To reinforce the concept, let's just try a few more examples. So now we'll add additional ticks between 0 and 1 on this line segment. Again, our first job is to find out how many parts are between 0 and 1. I know the ticks are not exactly even, but let's just pretend they are for our purposes today. So let's find out how many parts there are. We count 1, 2, 3, 4, 5. There's 5 parts to this line segment. We start at 0, and then we first have 1/5, 2/5, 3/5, 4/5, and then another name for 1 could be 5/5. This number line segment is divided into fifths. There are 5 parts between 0 and 1. Our final example for today. Let's add additional ticks to our number line. And again, as you know, our first job is to find out how many parts are on this line segment between 0 and 1. So let's begin by counting. And we see that there's 1, 2, 3, 4, 5, 6, 7, 8. So you tell me, what is this line segment divided by? If you said eighths, you're absolutely correct. There are 8 parts between 0 and 1. Let's name them if we have enough room here. We have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and another name for 1 would be 8/8. Again, this number line is very interesting. You can see right in the middle, as we discussed previously, the numerator is half of the amount as the denominator. So another name for 4/8 could be 1/2 as well. And we'll get more into the topic of equivalent fractions. But for today, that's enough of a preview about that concept. Our most important point and our most important topic today is always determining what a line segment or a number line is being divided by. How many parts are between the whole numbers? The whole numbers today were 0 and 1. This line segment happened to be divided by eighths. So your first and foremost job every time is to determine what the line segment, how many parts are in that line segment. Before we conclude today's lesson on representing fractions on a line segment or number line, an important concept is representing 0 in fractional form as well. The numerator will always be a 0, and the denominator will be the number of parts that are determined in each section or between the whole numbers on a number line. So once again, a fractional representation of 0 is 0 over whatever the denominator is determined to be by the number of sections or parts on the number line. That concludes today's lesson. Always count the parts between the whole numbers to determine how the fractional parts will be represented.